understanding regression in machine learning to see how predictions are made. Hey everyone, have you ever tried to guess what might happen next based on something you already know? Like estimating how much a house costs based on its size, or predicting how well you'll do on a test based on how many hours you study? That kind of intelligent guessing is exactly what we explore in machine learning using something called regression. What is regression anyway? Regression is a machine learning technique used to predict a continuous number, like price, temperature, or age, based on other information. Imagine you want to predict a student's final exam score. You have data from previous students, how many hours they studied, and what their final score was. Regression is the tool that helps a computer draw a connection between those study hours and the scores, so it can then predict the score for a new student based on their study time. It's all about finding a trend in the numbers. How do we find the connection? Correlation. Pearson's correlation coefficient, or just correlation coefficient, is a number that tells us how strongly two things are related and in what direction. Before we try to predict, we often want to see if there's even a relationship between the things we're looking at. For example, do more study hours generally lead to higher scores? The correlation coefficient gives us a number between 1 and +1. A number close to +1 means they go up together. More study, higher score. A number close to 1 means one goes up while the other goes down. Maybe more TV watched, lower score. And a number close to 0 means there's no clear relationship. So if our study hours and exam scores had a correlation coefficient of +0.8, that tells us there's a strong positive connection. More study, generally higher scores. Can we draw the best line? Simple linear regression. Simple linear regression is used when we predict one continuous number using just one other piece of information. Once we know there's a relationship, like between study hours and scores, simple linear regression helps us draw a single best fit line through all our data points. This best fit line is the straight line that most closely represents the overall trend between our two pieces of information. It's the line that minimizes the overall distance to all the data points. Think of it like this. If you plot every student's study hours and their score on a graph, some points will be scattered. The best fit line is the single straight line you can draw that comes closest to all those points. It's the general trend line. Once we have this line, we can pick a new number of study hours, find that spot on the line, and predict the corresponding exam score. What do the numbers mean? Coefficient interpretation. Coefficient interpretation is about understanding what the numbers in our regression model tell us about the relationship between things. When we have our best fit line, it has certain characteristics. One key characteristic is its slope, how steep it is. The number that represents this slope is called a coefficient. For our study hours example, if the coefficient for study hours is 5, it means for every additional hour a student studies, we predict their score will increase by 5 points. It helps us understand the impact of one thing on another. Can we predict with more information? Multiple linear regression. Multiple linear regression is used when we predict one continuous number using two or more pieces of information. Life isn't always simple. A student's exam score isn't just about study hours. It might also depend on how many classes they attended, their previous grades, or even how much sleep they got. Multiple linear regression allows our model to consider all these different pieces of data at once to make a more accurate prediction. Instead of just one line, think of it as finding the best fit plane or best fit shape in higher dimensions, considering all the factors together. It allows for a much richer and more realistic prediction. What about categories? Categorical variables in regression. Categorical variables are pieces of information that describe qualities or groups, like male, female, online, in-person, city A, city B. Regression can use these by turning them into numbers. What if one of the pieces of information we want to use is not a number, but a category? Like whether a student took the class online or in person. Regression can still use this. We just have clever ways to turn these categories into numbers that the model can understand. For example, online could be a 1 and in person could be a 0. The regression model then treats these like any other number to make its prediction. How good are our guesses? Evaluation metrics. Evaluation metrics for regression are numbers that tell us how accurate our predictions are. After our machine learning model makes its guesses, we need to know how good they are. We don't just guess and hope. Evaluation metrics are special measurements that compare our model's predictions to the actual results. For example, one common metric might tell us the average difference between our predicted scores and the actual scores. If this average difference is small, our model is making good predictions. If it's large, we know our model needs more work. These metrics help us understand if our model is a great guesser or just a lucky one. And that's a quick tour through regression in machine learning. From finding connections and drawing lines to using multiple factors, it's all about using data to make smart, continuous predictions. Understanding these concepts helps us see how AI makes sense of the numbers all around us. Thanks for watching and stay curious.